Alrighty, so let's go ahead and just review a couple things. So let's review that we have our trig functions, and so we have SOHCAHTOA. So we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then our tangent is opposite over adjacent. So we have our three trig functions that we're going to use. Now, identifying the different parts of your right triangle. Just as a short review, if we have A, B, C, and say we're going from angle C, our opposite would be that side that is directly opposite that angle, and then the adjacent would be the side that's attached, and then the hypotenuse is the longest side that is opposite our 90-degree angle. And so it doesn't matter, as long as we have that 90-degree angle, it doesn't matter what shape, as far as what shape, if it's sitting on its hypotenuse or if it's sitting on its side. So from angle M, this is our opposite, and then this is our adjacent, and then this is our hypotenuse. So that goes for identifying our sides. That's just a real quick review of how to identify your sides, so you know which trig function to use. Alright, now how to find the side length if you're given just one side and then the angle. Actually, what we're going to do first is we are going to look at some ratios and just see if we can go ahead and put them together. So we have our angle side, or our side length here, and say we wanted sine of A. Well, from A, our opposite side would be 16 over our hypotenuse, which is 34. Well, so we also want to make sure that we can reduce that, and when we reduce that, what are we going to get? Well, we want to make sure that we reduce it as far as it'll go, so we divide by 2 and get 8 over 17. And then we have cosine of A, and so we want our adjacent side, because this is our opposite, we want our adjacent side and our hypotenuse. So we have 30 over 34. Now, again, when we reduce that by 2, we have 15 over 17. And then finally, tangent of A is going to be 16 over 30, which is 8 over 15. So we have all three of our ratios to go with our triangle. Now, if we had the exact same triangle, so we have the exact same triangle, only we want to go from the other side this time, or from the other angle. And so if we go from angle C instead, we have our opposite side, and our adjacent, and our hypotenuse. So sine of C is going to be 30 over 34, which reduces to 15 over 17. Cosine of C, which is going to be 16 over 34, which reduces to 8 over 17. And then tangent of C, which is going to be 30 over 16, which reduces to 15 over 8. So you look, and remember also that when you have your sine of one angle, that's going to be the same as the cosine of the other angle. And then our cosine of this angle is going to be the same as our sine of that angle. And this happens because our two angles A and C are going to be complementary, but we're going to get into that a little bit later. So we look at our ratios and make sure that they are all reduced completely as far as they'll go, to make sure that that they are the ratios that we're looking for. So we can find our ratios, we know our trig functions. So what we're going to do next is find if we have a missing side length in order to find out what that side length is. So for example, if we're given a triangle, a right triangle, and this is 72 degrees and length of 6, and this is x, and then the next one is going to be 37 degrees and x and 12. Well, so we want to go from the angle that we're given, and from the angle that we're given our adjacent and our hypotenuse. So in order to find out which trig function we use, you can always write SOHCAHTOA on your paper just to make sure that you're keeping up with which trig function you're using. Well, so we have adjacent and hypotenuse, so we're going to use cosine. So cosine of 72 degrees is going to be 6 over x. Now we're dividing by x here, so opposite of dividing by x is multiplying by x. So we multiply by x on both sides, and that takes that x completely away. So then we have x times cosine of 72 degrees equals 6. Well, the x is still not by itself, so we need to get it by itself. So we're multiplying here. So the opposite of multiplying is dividing. So we're going to divide both sides by that cosine of 72 degrees. So x will equal whatever 6 divided by cosine of 72 degrees is, which is 19.42. Now you have to remember that your calculator has to be in degree mode for this to work. If you did not get 19.42 when you do that, make sure that your calculator is in degree mode. And if you look and you push your mode button and you look about 3 or 4 down and degree is not highlighted, make sure you highlight degree mode and then go back and try it again. That is very, 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 very important to make sure that you are in degree mode. Okay? So then on this one, from our angle here, we have our opposite side and our adjacent side. So the only trig function that uses both opposite and adjacent would be tangent of 37 degrees is x over 12. Now, we're dividing by 12, so opposite of dividing by 12 is multiplying by 12. So we have 12 times tangent of 37 degrees equals x. And when you go ahead and put that into your calculator, you're going to get that x actually equals about 9.04 when you do that. And if you remember, this is going to be your side length right here, wherever x is. That's going to be your side length. Okay? Now remember, you can pause the video at any time that you need more time to get your notes down. Okay? Alright, let's look at a couple more examples of those. So if we have an example like this one right here, where we have our 90-degree angle right there, and we have 24 degrees, and x, and 12. And then another example that we are going to use is, alright, so we have our 51-degree angle here, and we have our hypotenuse is x, and our side length is 14. Alright, so let's look. This one, we have our angle right here, we have our opposite side, and our hypotenuse. Okay? Remember, our hypotenuse is always going to be that side that's across from our 90-degree angle and our longest side of the triangle. So, if we were looking at our trig rules here, SOHCAHTOA, we can see that the one that we need that uses opposite and hypotenuse is sine. So, sine of 24 degrees equals x over 12. And that's just based on the ratio that we know. It's opposite over hypotenuse. Well, we're dividing by 12. So that means that we need to multiply by 12 on both sides. Now, just to reinforce why we did that, we are multiplying by 12 because right here we're dividing by 12. And we need to get x by itself. And since x is in the top of a fraction, we can go ahead and multiply by what's in the bottom to get it away. But when we do it here on this side, we also have to do it here on this side. So then we go ahead and we can put that into our handy dandy calculator and find that x equals 4.88. And you also just may want to make sure that the side that you're given is not the hypotenuse, so make sure that it's shorter than your hypotenuse. Okay? Alright, the next one, we have our angle here, and we're given our opposite side, and we're given our hypotenuse. So again, the one that we're going to use is sine of 51 degrees equals 14 over x. Alright, so x is in the bottom of our fraction, and we need to get it alone. But first, we need to multiply it on both sides. The reason that we did this is because we're dividing by x here. So the opposite of dividing by x is going to be multiplying by x. So then we have x times sine of 51 degrees equals 14. Well, our x is not by itself yet, so we need to get it by itself. So instead of multiplying, which is what we're doing there, we need to divide by sine of 51 degrees and then go from there. So we have sine of 51 degrees. Alright, so we have 51 degrees here. And then x will be by itself on this side because the sine of 51 canceled itself out when we divided by it. So we have 14 divided by sine of 51, which is 10.88. So when we and actually I misspoke, that is not going to be 10.88. It's actually going to be 18.01. So always make sure that you double check your answers when you look at it, because this side that we're trying to find is the hypotenuse, so it should be longer than any of the other sides that we have. And if we'd had that 10.88, it wouldn't have been longer than a side we have. So always double check with the picture to make sure it works. Alright, so that was all finding side lengths that we're missing. Now let's talk again about inverse trig, or trying to find the missing angle. So we go ahead and we have our right triangle here, and we have side length of 38 and then 27, and we're trying to find this angle right here. And actually instead, let's go ahead and just call that angle A. So we're trying to find angle A right here. So we have, from angle A, we have the opposite and the adjacent sides. So from our SOHCAHTOA that we know, SOHCAHTOA, we have the tangent function that we need. So tangent of A is going to equal 27 over 38. Alright, that is just identifying our ratio that we need. Alright, well, now we have our trig function of tangent. So the inverse trig function that we're going to need to multiply it by is tan inverse. So we're going to multiply both sides by tan inverse to try and get the angle that we're looking for. So we multiply both sides by tan inverse, and you can do this on your calculator by hitting the second button and then hitting the tan button, and that'll give you the tan with a little -1. Well, when we do that, these two cancel out right here and here because they're opposite functions. They're inverse functions. So if you have the tan with the little -1, the little -1, and a regular tan, they will cancel out. It's just like if you had 5 minus 5, they cancel out. Or if you had 4 divided by 4, they cancel out. So all you have left over here is A, and you have tangent of -1, or well, of 27 divided by 38. Now you can put that directly into your calculator just like that. But remember, you always want to double check your mode to make sure that your mode is in degree, or else your answers will not be correct. Okay, so 35.4 degrees is the measure of this angle right here. That angle right there is supposed to be 35.4 degrees. Alright, so let's look at another one. Remember, you can always stop the video at any point that you need some time to copy the rest of it down. Alright, so we have our two side lengths, and from angle B, we have our opposite side. And actually, I'm going to change colors. So from angle B, we have our opposite side and our hypotenuse. So the function that we're going to need is sine of B equals 40 over 42. Well, so since we have our sine function, we are going to use inverse sine on both sides. So we're using inverse sine on both sides, which means that we're taking it and multiplying it on both sides. And again, you find this on your calculator by going to second and hitting your sine button. Okay? Alright, and again, our two inverse functions are going to cancel out. So we have B equals sine inverse of 40 divided by 42. Now, again, when you put that into your calculator, you will find that your angle measure of B is going to be 72.2 degrees. Always remember that we're in degree mode, so the angle of this angle B is 72.2 degrees. Alright, so let's look at a few more examples of those, and then I'm going to give you some of both to do on your own, and then we're going to come back and we'll look at something else. Alright, so let's look at another example. So we have our triangle, and we're going to call this angle X, and 39 and 10. Alright, well, from our angle X, we have our opposite side, and then our hypotenuse, which is our longest side here. So we're going to use sine of X equals 10 over 39. Well, we're using the trig function of sine, so we need to use the inverse of sine on both sides. So we'll multiply sine of X times sine inverse, and multiply, and then we'll use the 10 over 39 in our sine inverse over here. Alright, so again, since we have inverse functions or inverse trig there, those cancel out, so we have X equals sine inverse of 10 divided by 39. So when you go ahead and put that in your calculator, you're going to get the angle of our triangle, and it's 14.9 degrees. Okay? And so always make sure that you just double check to make sure that everything is put together correctly. Alright, so let's look at one more example of this, and we're going to look at this example that actually has multiple ways of solving it. So we're going to look at angle A with side length of 56, 42, and 70. Alright, so there's multiple ways to handle this one. The first one is you can go from this angle and say this is your opposite and this is your hypotenuse. So you can use sine of A is 42 over 70. And since we're using the trig function of sine, we have to use the sine inverse on both sides to find our angle. And so we have, sine of A, and then we also have sine inverse on this side of 42 over 70. And because of these two, we go ahead and we mark them out because they cancel out. They're inverse trig functions. So we have angle A is sine inverse of 42 over 70. And when we find that out, we find that's 36.9 degrees. So that's using sine. Now, we could have said, alright, well, instead of using the opposite side, we're going to use the adjacent side, which is here. So we could use cosine of A is 42 over 56. Excuse me, 42 over 70. I am so sorry, that's not even close. It is 56 over 70, jumping ahead here. So, and then again, since we're using our cosine trig function, we can use cosine inverse to go ahead and find our angle. Now, when you do this, do you think that you're going to get the same or something different than what we already have? Well, if you said we're going to get the same thing, you would be right. So 56 over 70, now that we have that ratio correct. And we're going to go ahead and we're going to cancel those out because they're inverse functions and find that A is cosine inverse of 56 over 70. And when we find that out, we find that angle A again is still 36.9 degrees. And that's crazy to think about because we use sine in one and we use cosine in the other. But as long as we match up the correct side length and the correct ratio with them, it should work out. And last but not least, we could have used opposite and adjacent, since we know the opposite side, and said that we want tangent of A is 42 over 56. Now I have that correct. And since we're using the tangent trig function, we can use tangent inverse on both sides to find our angle. So we have, and I had to write it down here because I was running out of space. And we have 42 divided by 56. Alright, well I'm going to shorten this up just a smidgen and say, alright, we canceled those two and we find that A equals our tangent inverse of 42 divided by 56, which when we do that will still give us 36.9 degrees. So this one, since we were given all three sides, we were given the hypotenuse, the adjacent, and the opposite, we could have actually used any three of the trig functions to find it, and it is totally your choice. But you may want to just double check and use another one just to double check, make sure you're correct. So on your own, I'd like you to do the next few questions, and you can pause the video after I get them down and work on them and then come back and we will talk about them. So the first one, we have our right triangle here, and this one's kind of a little crooked from what we're used to. We've got 33-degree angle, we have 29 length, and then we're finding x. So that's finding a side length that you don't know. And then we have this one where we have a 19-degree angle and x and a hypotenuse of 29. And then we're going to have a few with the angle missing. And so we're going to go ahead and just look at this one. Alright, and we're going to go from this angle here, and we're going to say that this is 14, and this is 48. And then last but not least, we're going to have, let's see, we'll have this one. And we'll go from this angle here, angle x, it's an x, and say that this side length is 6 and this one is 8. So go ahead and work on those on your own or in groups, and then you'll pause the video and then you'll come back and we'll work them out. Okay, welcome back. So as you can see, I have went ahead and put some of the information down that we would have used. So for number 1 here, we have our sine function of our angle at 33 because we have our opposite and our hypotenuse. And so we're going to use sine of 33 equals x over 29. And that's written right here. Alright, and then we multiply by 29 on both sides, and we get 29 times sine of 33. And when we multiply that out, that will give us our side length that we're missing, which is 15.79. And so that is our side length of that triangle. Now for number 2, we have sine of 19, because again we have our angle and we have our opposite and our hypotenuse. So we have sine of 19 is x over 29. We multiply 29 on both sides to get our side length that we have, which is going to be 9.44. So we have our side length then of 9.44. And then for 3 and 4 we have, we're looking for our angles. And so we have our angle, and we have our opposite and adjacent, so we're going to use tangent of A is 14 over 48. We're going to use the inverse of tangent, which is tan inverse. It cancels out our trig function, so we have A equals tan inverse of 14 over 48. And that will give us our angle measure of 16.26 degrees. Don't forget your degrees, because we are still talking in degrees here. Alright, number 4. Again, we have our angle right here, and we have our adjacent side and our hypotenuse. So we're going to use cosine of x is 6 over 8. And then we're going to use cosine inverse to find our angle measure, which is 41.4 degrees. So we have our 2 with the side length missing, and then our 2 with the angle missing. So hopefully you've understood that, and if there's any extra work with that, you'll be using the same kind of idea. Alright, so let's look at a couple of questions just to review as well. And so we have our triangle right here, and we have, it is ABC with a 30-degree angle for angle C. Your question is going to be, which of the following could represent AC? And that is side length AC. So we're looking for what could represent this side length right here. Okay, so that's what we're looking for. Now your answer choices are A, AB over sine of 30, B, which is AB times sine of 30, C, which is AB over tangent of 30, and D, which is AB times tangent of 30. Alright, so let's look at this one. So we are looking at our triangle right here, and we're trying to find what will give us this side of AC, this side right here. Alright, so let's look from this angle. What are the 2 trig functions that they give us? Well, they give us a sine function in 2 of them, and then they give us a tan function in 2 of them. So let's look at the sine function first. So from this angle of ours that we're given, the 30-degree angle, if we were going for sine, we would need the opposite, which is here, and our hypotenuse, which is here. So if we are using sine, we would know that sine of 30 is going to be AB over BC. Okay? Well, so we look at our function here. Do we even have an AC in our trig ratio here? No. So we don't even need to look at sine anymore, because we don't even have our AC, what we're even looking for, in our trig ratio. And since we don't have it in our trig ratio, we can move on. So we go ahead and cross out A and B. Can't be sine. Alright, well, so then let's look at the tangent of 30. So let's redraw our triangle down here so maybe we can see it a little better. So we have ABC, and we're looking for this side right there. Well, if we use tangent from this angle, we need our opposite and our adjacent. So we look at tangent of 30 is going to be AB over AC. Well, there's our AC. That's what we're looking for. There's our AC right there. So we need to figure out what combination. Is it going to be AB over tan of 30, or is it going to be AB times tan of 30 that will give us AC? Alright, so let's look at this. So we have our function set up according to our side lengths. Well, we're dividing by AC. So instead of dividing, we need to multiply to get it out of there, because we need to get AC on its own. It's just as if AC was X. So then we have AB equals AC times tangent of 30. Alright, well, AC is not alone. AC is not by itself, and that's what we're looking for. We're looking for AC to be by itself. So we're going to divide each side by tangent of 30 so we can get AC on its own. So we have tangent of 30. So if we look at this answer right here, then we have AB divided by tangent of 30, which is C. So we have the answer of C. And of course, we could always try putting numbers in there to make sure that it's true, and just to make sure that we did it correctly. Alright, number 2. For example, if we have a right triangle that looks like this, say it's XYZ, with side length of ABC, and we have this angle at 57 degrees and this angle at 33 degrees. Okay? Your question is, which of the following, that means it's going to be multiple choice, which is always really nice, could represent tangent of X? Alright, and so we have our first choice here, which is A over C, and then we have B over C, and then we have A over B, and we have B over A. Alright, so let's look here. We have our answers, and we're trying to figure out which one's true. So we're using tangent of X. So we're looking at, from this angle, we're looking at our tangent of that angle. Well, tangent, we know, is opposite over adjacent. So this is our opposite, this is our adjacent. So we know that tangent of X is going to equal B over A, which is D. So you might want to always check and make sure that you are using the correct side lengths and not using the hypotenuse when you should be using the adjacent. Alright, and the last one, we have our right triangle, and it's going to be MNO. And given MN equals 5. What other information, so what other info is needed to find the sine of M? Alright, so we have our answers of MO, angle N, or NO. Alright, so we're given that MN, so this length is 5. That's what we're given. And we're looking for sine of M. So we're looking from this angle, we're looking for the sine. Well, we know sine needs the opposite side and the hypotenuse. Well, we have the hypotenuse, so what is the other thing that we need in order to find the sine? Well, we need side NO. And I know most of you are probably going, no, but it's true. We need side NO.